Assalamualaikum and good day. My name is Iffah Aqilah binti ISMAIL, mechanical engineering student from Uitm Shah Alam. For today's presentation, I'm going to present to you about my research proposal, which is study on the tribological characteristic of food-grade bio-lubricant using 4-ball experiment. So today's presentation will start with introduction of this research, then objective, methodology, research outcome, and lastly my Gantt chart. First, what is lubricant? Lubricant is a substance that is intended to reduce friction, wear, and heat between contacting surface in relative motion, and also is used to reduce passive resistance of stationary part in mechanical system in order to sustain the system as it operates smoothly for a long period of time. They can be classified based on their physical appearance, which is solid, liquid, and semi-solid. So in this lubricant sector, there is a lubricant that are classified as food-grade lubricant. According to National Sanitation Foundation, food-grade lubricant is a special type of base oil and additive that is safe for use in packaging equipment, food, and pharmaceutical processing environment where there is a chance of incidental food or drug contact, which is classified as NSF Class H1 standard. So basically, there are three types of base oil, which is mineral, synthetic, and vegetable oil base. Currently, in the industry, they usually use the mineral or synthetic oil-based lubricant. Mineral oil-based lubricant are petroleum-based hydrocarbon that derive by distillation of crude oil. They are organic but rarely biodegradable and can cause environment pollution if they are spilling. While vegetable oil-based lubricant are extracted from plant products like seeds, nuts, and fruits. It is organic, biodegradable, and reusable, and less impact towards environment pollution. So for this research project, I have chosen palm oil as my additive, which will be added to the commercial industrial gear oil. So why palm oil is chosen? From my literature review, the result shows that palm oil produces lower coefficient of frictions and establish strong stability of lubricant film. And in Malaysia, it shows that palm oil is promising renewable sources as its high production rate, which can fulfill the demand for a vegetable-based lubricating oil. Some previous researchers also have done some research about developing palm oil as lubricant, and it has shown satisfactory result and has a bright future in engineering application. Therefore, the use of mineral oil-based lubricant is being replaced by biodegradable lubricant as environmental concern, and their toxicity are becoming more publicly recognized. According to the recent study, vegetable oil could replace conventional lubricant in industrial and automotive sector. However, vegetable oil somehow does not make a suitable industrial gear oil because of its poor low temperature performance, low oxidative stability, and poor thermal stability. And lastly, the application of food-grade biofluid for industrial gear oil is not well understood due to the lack of research and information which drive this research project. Hence, the objective of this research project is to measure the friction coefficient and friction torque of biofluid used with different composition of gear oil and to determine the wear preventive characteristic of the lubricant based on the wear scar diameter. So the scope and limitation of this project are as below, where this project will undergo a procedure for making a preliminary evaluation of anti-wear property of this lubricant by using 4-ball tribometer machine. The oil sample for this project has the same base oil, gear oil, with different concentration of palm oil as the additive. Next, the control parameter for this experiment are apply load, rotating speed, and temperature of the ball cup, which is adjusted according to ASTM D4172 standards. Lastly, the coefficient of the frictions and the wear scar diameter will be analyzed by the tribological characteristic. It it hypothesized that palm oil blend with industrial gear oil VS220 will increase the lubricity performance, which resulting in small West diameter and low coefficient of friction. So to achieve the objective of this research, this is the progress flow that I will execute throughout FYP1 and 2. Firstly, I must review articles and journals to find the suitable characteristic of biofluid related to the tribology topic. Then, I need to prepare the 4-ball test material and the oil sample that will be tested. The sample should follow the standard requirement for 4-ball tests. Next, I will run the tribological test using 4-ball wear test machine at the tribology lab, and it will give the frictional torque and wear scar as a result. The important part is I need to check the reliability of the result. If everything is fine, then I can proceed to the data analysis process. Lastly, the coefficient of friction and wear preventive characteristic is determined and the objective is achieved. So here is what I need to prepare, which is the ball bearing and the oil sample. For ball bearing, I need to purchase according to the ASTM standard. This is because to ensure that the ball bearing will give the desired result. The test ball and apparatus need to be cleaned by N-heptane and wiped dry using a fresh, clean-free industrial wipe. Other cleaning agent also can be used, but it must recognize as harmless, able to remove anti-rust coating from the ball, prevent test oil from carrying over from one test to the next, and not cause the test lubricant to wear out or act as anti-wear agent. Next is the preparation for the oil sample. This experiment will use gear oil as base oil with 6 different concentrations of palm oil will be mixed by using a mixer. The oil composition is determined by do some research review from previous study about 4-ball experiment. This 6 different oil composition is expected to give different tribological characteristics. The 4-ball test is a technique that can be used to assess the lubricants, frictions, and wear preventive characteristics. There will be 3 12.7 mm diameter steel balls clamped together and covered with the test lubricant, and the 4th ball will then be placed on top of the 3 balls. Then, for 3-point contact, a weight of 40 kg is pressed into the cavity created by the 3 clamp ball. The top ball is rotated at 1200 rpm for 60 minutes after the test lubricant temperature is set to 75 degrees Celsius. So this is the summary of 4-ball procedure. Started with cleaning the material and apparatus using the N-heptane, and then tighten 1 clean ball to the machine spindle and assemble 3 in the test oil cup. Then hand tighten using the wrench approximately 2.8 to 5.6 Nm. Next, put the oil sample into the test oil cup to a level at least 3 mm above the top of the ball. Lastly, run the experiment according to the parameters set explained before and measure the wear scar on the 3 lower ball using the Aqilah microscope. So the tribological characteristic that I'm interested on is the wear scar diameter, which can be determined by the optical Aqilah profilometer microscope, and the coefficient of friction calculated based on the friction torque from the 4-ball machine. The wear scar diameter, we will measure it for each oil sample. This graph shows the example of expected result to compare the wear scar diameter for each composition. Generally speaking, the more severe the wear, the greater the wear scar diameter. Then for lubricant, coefficient of friction is crucial. The coefficient for each composition is determined by this equation, and this graph is plotted and generated. For gear oil, it is targeted that the coefficient of friction is between 0.08 to 0.14. So here is my Gantt chart for semester 7. And this one is for semester 8 for final year project 2. Thus, this is the references to complete this proposal. That's all from me. Thank you.